Okay, good evening, everyone, and welcome to our second class this week. And we're continuing with orchestrating AI agents with LangGraph. Um, I had already sent the script that we'll use for our demonstration in today's class. I've sent that to the Discord channel, so I expect that you already have copied that up in your ID and that you've already installed the um, new dependency that we're going to make use of today, as well as obtained your the API key for Davidi search, which we'll be using in that script. So as usual, we'll start the class with a recap of what we did in the last class. In the last class, we looked at conditional edges in LangGraph. So who will be gracious to provide us with a recap of what we talked about in the last class vis-a-vis conditional edges and LangGraph? Yeah, Kenneth, please go ahead.
Okay, so last Wednesday, like we
That was
I
Tuesday.
think like we sorry Tuesday. So like we touched on a fixed edge and the conditional edges. So the fixed edge in this case is a static path or a deterministic path. So if I'm supposed to give a scenario, maybe I will make a search to the web, and the web will give me um, and it will give me a response. So like this approach is like very static from this path to this path. So from me making a search to the search like giving me back a response. So like this is a fixed edge. Now, like we also have a conditional edge. In the conditional edge, what happens is it look at the current situation and it makes a decision based on the situation. So another like scenario here would be um, a chef who is trying to like make a meal. So during the process, he realized that maybe like there is no salt. So the chef will add a salt. So like based on the circumstances, it like reacts. Sorry. So like based on the circumstances, an action is being made. So like we proceeded to a routing function. So the routing function is on a high level is being referred to as the it determines where to move next or like where to go next. So it takes in the user input, and the input here is the state. And based on the state, it determines where to go next, as I already said. It uses three rules. The first rule is there has to be a state. The second rule is it reads but it never writes. And lastly, it's supposed to return a key. And I would like to proceed, but like there is this thing called a path map. So the path map takes in the key and it returns the specific value which is being attached to the key. And I think there is something on routing function that I've forgotten. Okay, so I will touch on the good strategies and the pitfalls. So one of the best strategy is we should keep it simple. We shouldn't over engineer the routing function. We should ensure that the routing function is simple and very fast too as well. And that we should avoid infinite loops and our recursions to also have limits. So this is what I remember, giving a rough summary of what we've done. So if anyone can also add up, I'll also be glad like to learn from what my colleagues also have. So, thank you very much.
Okay, thanks a lot, Kenneth. Does anyone else have something to add? So as a recap of functional edges, whether you were there in the class or you watched the class video, anyone else have something to add to what Kenneth has already said? Okay, apparently no one else. I'll just add that unlike fixed edges where an edge is like the path, the connection between two nodes, right? A fixed edge, in a fixed edge, when you are at a particular node, you must go to a specific other node. It doesn't, the next node doesn't change. But with conditional edges, you from a given node, you can go to more than one node, two or more nodes. But the specific one that you go to depends on the states of the agent at that point. And the routing function, the function that defines the logic that specifies which node the next node to go to based on the agent state. The routing function outputs either a Boolean or a string that specifies like a specification of that next node. And the state map is the dictionary that maps the output of the routing function with the specific node that the agent should move to next. That's certainly the other thing is the different agentic AI patterns that integrate conditional edges and use a routing function. We mentioned a few of them, so we could get that from the video of the last class. So we move ahead from here. Now, today, we want to look at edgeless graphs, right? Before we went on break and in the last class, before we went on break, we talked about fixed edges. In the last class, we talked about conditional edges. Now, the thing is, whether with fixed or conditional edges, there's an edge, right? There's an explicit edge in the graph. But in LangChain, it's possible to define a graph, an agent graph, without explicit edge definition. And such graphs are called edgeless graphs. Now, in edgeless graphs, the nodes, they have the ability to decide themselves. A node has the ability to decide on the next node, right? When we talked about the graph's explicit edges, we talked about the different methods that you can use to define edges. For fixed edges, you use the add edge method. And for conditional edges, you use the add conditional edges method. But in edgeless graphs, there's no method to add any edge. I mean, the nodes themselves, they are able to decide on the next node to go to on the destination at one time. So this decision is determined at runtime, like I said, and the node specifies that in its return value, and it uses what an object called the command object. So for edgeless graphs, the return value must be a command object. And that command object specifies the next node to go to. So there is actually really an edge, but it's an implicit edge, right? And so such graphs are dynamic. The advantage of edgeless graphs is that they decouple the routing logic from the definition of the graph. With explicit edge graphs, your routing logic is based on this. You need to define the explicit edges for the graph, whether fixed or conditional, and your routing logic makes use of these predefined edges. But in edgeless graphs, your routing logic does not. I mean, okay, let me say it this way. With explicit edge graphs, if for any reason you add a new edge or you remove an edge, you need to modify your routing function, as your routing function is aware of these edges. But with edgeless graphs, the routing logic is decoupled from the graph definition itself, such that it makes it easy. It makes it easy to modify your agent graph logic, since the routing logic is decoupled from the graph definition, such that you don't have specifically you don't specify the edges. So whatever your node outputs with the command object forms an edge, so long as there's actually the output of the command object corresponds to a node. So as long as such a node actually exists in your graph, that's fine. So you don't modifying your graph is more dynamic with edgeless graphs, and they help to reduce complexity, especially for, they reduce boilerplate code, especially in complex and multi-agent systems. I mean, your agent architecture can become quite complex, and if you have to define explicit edges, that makes for some uninteresting code, especially when you need to make modifications and you need to manage, maintain the code. Any questions so far? Okay, so go ahead. So we mentioned the command object as the return type of nodes in edgeless graphs. So yeah, the command object, it's made up of an update. Those are the parameters. The update is a dictionary that contains the update that you want to make to the state. So you just, if there's any component of the state that you want to update, you just provide that key, a dictionary item, the key and the new value you want that component of the state to have, and LangGraph knows how to update the state once the nodes function returns. And then it has a goto, which is a string. The value for goto argument is a string that it's the name of the next node. Typically, what you would just the string name of the next node. And here is an example. Oh, there's a missing D there of the command object. So the update here, you want to increase the count to 1, and then the next node you want to move to is the processor node. So here, by returning this, you have essentially defined an edge between the node where this code is defined and the processor node. if you change this on the fly to maybe some other node, say a critique node that defines another edge, this is quite dynamic. The command object allows for dynamic edge definition, which is the key thing in edgeless graphs. Now, we'll look at some edgeless graph patterns. The one here, we'll talk about the dynamic dispatcher. So the concept here is that you have a central node which acts like a dispatcher or a manager or a router, as the case may be. Now, when the user provides a query, the dispatcher analyzes the task, of course, figures out the intent and so on, and then it decides on the most suitable expert from a list. So, in the dynamic dispatcher pattern, there is a list of experts, right? The dispatcher analyzes the user query, figures out the intent, and based on that, it decides from among that list of experts which is the most suitable to handle the user intent. And then it returns a command object whose go-to argument is set to the string name for that selected expert node. And so the request is routed to that expert node that has been selected, which handles the request and the graph execution from there. It's quite scalable in that new expert nodes can be added to the graph without needing to, it's using an edgeless graph. So just like I mentioned, in edgeless graphs, you can dynamically, you can not really dynamically in the sense of a runtime, but it's more dynamic it's easier, it's more seamless to add new nodes to the graph. Of course, those nodes will correspond to an edge because those nodes will connect most likely, except the end and start edges. Every other edge will connect to some other nodes, forming an edge. So you can easily add more nodes without having to define explicit edges in the graph. Any question so far? If you have a question, just indicate by raising your hand. Okay, no question. Now, okay. So you have a question, please go ahead.
No, I don't have a question. I was just giving a thumbs up.
Oh, okay, okay. All right. So we go ahead. Now, how do we manage handoffs with dynamic returns? The dynamic returns are what we have with the command object that graphs have their return value. So how the problem here is you have an expert agent node in the dynamic dispatcher pattern we talked about, for example. You have an expert agent node. How does this expert agent node know where to go when it finishes its task? No, we described that in the dynamic dispatcher, for example, the dispatcher node, it analyzes the task, figures out the intent, and decides on which expert node out of the list it has, the expert node that is most suitable to address that intent, and then it returns a command object with the name of that selected expert as the value for the go-to argument. So the implication is that LangChain, the graph execution will move the next node will now be that selected node, right, which is the expert. Now, when this expert has done its work, right, when he has handled the task or that step in the task, as the case may be, how does it know where next to go? And that's what the dynamic returns. So the dispatcher there can be a state a member of the state object called return to, which can be set to dispatcher. For example, the name of the dispatcher agent or node, that's the case may be, so that every expert agent node that finishes its work can check the value of this state object, this state member or property, as the case may be, and then it returns that as the go-to in the command object that it sets that as the go-to value in the command object that it returns, so that after each expert is done with his tasks, it returns the execution back to the manager agent, and then the manager agent analyzes and figures out whether the user's intent has been achieved, in which case it returns the final response to the user, or if it's necessary there are still more steps to be taken, it figures out the next expert node to hand over execution to, and it returns a command object with the go-to value set to the name for that newly selected expert mode. So command really is the trump card. It's the key element, if I may say that, in defining and executing headless graphs, and its value is really very, very evident when you have complex nested subgraphs. So for navigating through them, it's really, really beneficial there. So what are the best practices when you're trying to build headless graphs? Firstly, how do you name the nodes? Your nodes need to have consistent names across your application. I mean, the consistent naming is really an important principle in software engineering as a whole. So it's also important here. So you should your node naming should be consistent across the app. It's good practice to use literals in your command object. So like in the go-to, when you are in your typing of your function signature, so you specify that the command what it returns, you use literals for it, such that it reduces the likelihood of a typo, creating bugs, exceptions at runtime. So with static typing, or as close to it as Python provides, type hints enables some IDEs to catch such bugs before you get to a runtime. So it's a good practice to use literals. If you look at the example codes that I sent, you'll see that almost all the command objects use literals. We're going to see that shortly here in the class. Now, for state management, it is important to note that command updates is the primary way to update the agent state. Once you provide that dictionary value to the update argument, LangChain LangGraph knows how to update the state, and the specified keys in the state object will have the new values that you provide in the update argument by the time we get to the next node. It's good to be aware of the dangling node risk. I think mentioned this in the last class when talking about the browsing function, where I stated that it's important to ensure that every possible output stream of the routing function must be represented as a key in the path map, because if there is an possible output string of the routing function that does not correspond to a key in the path map, it means that whenever the routing function returns that specific string, the graph will not know what node that corresponds to. So you have a tangling node. So in this case, a node every command object must include a goto argument, because without a goto, there is no edge. So it's the goto that forms an edge because it specifies the next node in the execution path. So if you omit this, then you have a download of the specific node from which that has that command object will not have an edge to any other node. So once the execution gets to that node, the graph will stop. It won't know where next to go. Any questions so far? Okay, so basically that's the talk for today's class. The next thing we do is to look at the demo code and try to run it, and you should also try to do that and discuss the code and see what the limitations are, the possible improvements that can be made. So I'll stop sharing my screen for a bit, and then I'll call up the code and then share my screen again. Just a moment, please. Please indicate with a thumbs up if you can see my screen. Okay, thank you, Natsu. Can anyone else see my screen? Okay, thanks, Daniel. All right, so I would assume, thanks, Lawrence. I assume that everyone else can see my screen. Please, I think it would be nice if you, well, I assume that you also have this code in your own IDE and can also run. So let's walk through the code. I think in previous scripts that we've run, we've used synchronous methods for calling our LLMs and chains. But today we are going to make use of one of the asynchronous functions. The asynchronous methods, they are the different methods that you can use to invoke a runnable, a LangChain runnable, include invoke, that's for synchronous, invoke, stream, that's a synchronous streaming, and there's a stream, right? So today we're going to use a stream. I would advise that you try to play around with using these different methods so you can get more familiar with how each of them behaves. As we've been doing more recently, we have made this script so that it's easy to toggle between using models on Grok and then using local Olama models. Well, Grok, I think for our demonstration, we'll use Grok, because that'll be faster than Olama, but then that can also use up, you can also hit the using limits. I've specified the API keys for Grok as well as for, we're using Tavili here, right? Yep. Well, okay. We're using Tavili search as well as for Tavili. Now, over here, this is just the same thing we've been doing, define model names. I would also advise you to try this with different models. Here is just a Llama 3.3 70B variant, and then Llama 3.2 for Olama. So now we'll be executing with the crop model, so it will be Llama 3.3 70B plus fire. Search for search, we are using Tavili search, and here I've specified that it gives maximum of 3 results. I mean, you should also play around with this, but the more results you specify, I think more the faster you can also hit their limits, even though that really has quite a generous limit, I must say. I don't think I've ever hit the search limit with the free tier, even though I've not really done so complex search and with it. Well, complex in terms of the volume and recurrence. Okay, so we define the agent state here as a type state with the following members: a query, which is the name is obvious. What is it's reset data will contain the search response we get from Tavili. Okay, beforehand, this is essentially a simple research agent. A simple research agent. You ask it a question, it goes on, it does a web search, it writes a draft, and it tries to critique that draft to see if the draft meets if the draft is adequate to answer the user's query, it outputs that at the final response. But if it's not, it goes through a correction loop and tries to update the draft. It will keep on running in that loop until it gets a draft that meets that is adequate, that adequately addresses the user query, or it hits is the cycle, excuse me, the iteration. It has more iterations than the revision count. And so we define the nodes. We have the reset nodes. I had mentioned that essentially the nodes will take the states as inputs, at least the states, because the state is what enables the sharing of information between the nodes. It's what defines the current I don't want to use states to define state. The current condition of the agent. So it allows nodes to share information. A node is typically not aware of any other node. So it's essentially the state that allows them to share whatever information that you want them to share as you're building the agent. So our research agent just invokes the Tavili tool search tool we defined earlier to use the Tavili search. It just calls that tool with the query. And here, these print statements are really redundant, but I have them here to give us help us have a more in-depth view of what is happening as the agent executes. This tool is here. This data here is just a concatenation of the results from the search results from Tavili, and that's what is used to update the states, the reset data member of the agent state. So when the reset node executes, it updates the state with reset data set to the data that was returned by Tavili, of course, now as a string, and revision count set to 0. At this point, there has been no revision to the draft. Of course, the draft has not even been written in the first instance. And then the go-to value is set to writer. So, like I mentioned, it searches the web and then it uses the results of that search to write a draft report, for example, and it's the writer node that generates that draft. So we go to the writer node. Yeah, I mentioned that it's good practice for the command to use literals. Here you see I have a literal for writer, so that it makes it easy to type check, assuming you make a mistake, maybe omitting one letter or adding an extra letter or misspelling that. So your IDE, it helps your IDE to catch such bugs before execution. So the writer node, essentially, here it uses an LLM. The prompt here is for it to draft a concise report based, well, in this case, response, I just said response, this response is a report, but based on the data provided, and asking it to cite the sources of its information. This is the system prompt. So here we have both a system prompt and a user prompt. And then if there is a critique, if there's a critique of that draft that it has generated, it should address the critique. That's what this is doing. So if there's a critique key in the state, if there's a critique member in the state, then it should address that critique. If there is none, then this is no longer part of the system message. And then this becomes the user prompt, where it provides the data retrieved from the search and the user query. And we run the LLM, we invoke the LLM with the prompts and return a command with the draft updated to be the whatever draft the LLM comes up with, and the go-to argument set to critique. So the next node will be the critique node. Now, the job of the critique node is essentially just to let me make this so that it becomes more visible. Okay, so it's essentially to determine whether the draft accurately and completely answers the user's query. So it is to return the word approve, all caps, if it determines that the draft has fully addressed the user's query. Essentially, that draft, does it do what handle the user intent? But if it does not, then it should provide specific feedback, like a critique of the draft that was provided to it. And now, for the return, we're saying if there's a proof in the response from the LLM, then, or if we have done more than more than the revision count, more than the one specified. I'll show you where the revision count value, is still a part of state. In this case, in some subsequent examples, we are going to put that in the config object. So if we have revised more than twice, then you should go ahead with that draft. There's no this helps to avoid an infinite execution loop. And then, as we had before, these are really I just put these for us to get an intimate look at what is happening as the agent executes. This just prints out the final draft if the critique node says, yeah, I'm fine with the draft, or we have had too many revisions. And then the go-to command has its go-to argument set to end. That's the end. Terminate the loop. I mean, if you've been able to address the user's intent, we terminate the loop, or if, in this case, if you have done more than the maximum specified iterations, terminate the loop. But however, if neither of these two conditions are met by the output of the LLM, then inform the user. And for me here, I'm saying inform the user and tell us what the feedback of the critique node is, and then go to the writer node. So the writer node needs to rewrite that draft and then try to address this feedback that the critique node provided. That's where we said, if there's a critique, then address that critique. And that's essentially it. So here we are building the graph just like we did in the others. Now notice that there is no add edge typically, but we just have one here, one static edge here, which is from the start, where we specify that the graph's execution really starts from the researcher node. You need this, otherwise LangGraph will not be able to commence executing that graph. Apart from this, no other edge is defined in this graph. And then you compile the graph. And here, to execute, we use it's asynchronous. Yeah, I mentioned that we are using the A-stream method to invoke the graph. And essentially what we're saying is at each event in the graph's execution, print out that event. That also allows us to see what is happening at each step in graph's execution. So I'm going to I'm going to run this now, and now while we're waiting for it to execute, did anybody try before now to run the code? Kenneth, you did? Okay, that's good. Let me just talk. about this. So notice it started with the research node, like we defined, and this would show you what I put this here so that you can see the structure of the response from the Tavili search. From Tavili search is just a dictionary, so you can look at this later when you execute the code yourself on your machine. Now this is from our async 4, where we're asking it to print out each event as the graph executes. And so this is saying the event here is the researcher node is executing. And so it gives you the value of the update of the command object. So in this case, what we're updating was the reset data. Was there anything else we updated there? I think it's just the reset data. And the next node was the writer node. And notice here, that's the next event, writer node. We updated the draft. Okay, I think in the researcher node, we also set the iteration count. I've forgotten the name that was used for that. We set it to 0 something. Yeah, revision count to 0. And then next is critique node. And the output here is saying that, I mean, it's suitable. That was what we asked for. If approve, I think it's approved, is in the output from the LLM, then we will print out this result is suitable and ending process, and then we print out the final draft, which is what we had. So that's the report from the LLM, and just as we asked it to, it was citing its sources. Now, if for some reason the critique node determines that the draft does not fully and correctly address the user's intent, we are going to see it looping between the critique node and the writer node, critique node and writer node, until either the critique node is satisfied with the draft or we exceed the maximum revision count. Okay, was it Daniel or Kenneth who said they had tried to run the code? Could you tell us what were your own results and what LLM provider did you use?
Okay, so let me I'm coming. Let me check again. So I use I use Grok to run it, and I use the LLM. Let me see. Then like the 3.7 something. I'm checking it from my um, so I use the Llama 3.3-7B / I'm not versatile. So like that was what I used. Now let me give my results. Okay. I am not running it again so that I could give my results. Okay. Please. I'm not. Which like results like do you want me like to give? Say, because I have the final draft. I have the references.
No, just
Um.
just just give us
Yeah.
like a description of. You don't need to read it out. Just give us like a description of what you got. Was it similar to what we got here, or
Yes, I think like quite similar, but I could share my screen like for a second, if like that would not mind. But it is like same as what you also have. So
okay?
yeah,
That's fine. Just wanted to know whether it's the same. So, what I want to do
yeah.
now, I want to try with a different model, right?
Okay.
Let's see what this same query will give us, and then we'll also try a different user query. Okay. So I'm trying with GPT OSS 20B, sit on Grok. The only difference most likely would be in the writer node and the critique node, which those are the only nodes that make use of LLMs. For David, the search is the same Tavili agent. The same Tavili service. Now, see that this is more verbose. And see here, the critic says that it is not suitable. The feedback is the draft contains several inaccuracies and is overly detailed for the question asked. And it provides specific feedback in a table. What is the issue? What makes the problem? And it suggests a fix. And it even suggests a did I see somewhere it said revised? Yeah, says revised example, revised answer example. Even suggests um, a more appropriate response. And so the writer node tries again. The critique node still says that is not okay. And then we still go again. Okay, I think this time now we have exceeded the maximum number of specified revisions. So that final one is provided as the final response. So notice that in the case of by using GPT OSS 20B, the critique node is a bit more critical. Of course, it was still the same LLM that did the power the writer node. It's quite possible to use different LLMs, a different LLM in the writer node and a different LLM in the critique node. In this case, you need to use an LLM that provides the best outputs in drafting the replies, and use an LLM that provides the best take of that report. That will give you a more valuable performance, of course. Performance in the sense of the stability of the agent's response to the user. But of course, in this case, you're using multiple LLMs, which, depending on your specific architecture and the providers you're using, may be more expensive. But luckily, um, for us, that might not be the case here. So you could actually modify this code to use different LLMs for to power different nodes that require reasoning in elements. So who can tell us a different query to try? Anyway, one thing I have observed with the OSS models is that they tend to be more verbose than the Llama 3 models. That's one thing I have observed about them. So who can suggest a different query that we can try? Yeah, the query that we have is what is the latest development in AI as of December 2025? Okay, I think there's actually I have another query here, so maybe we use that one, which is what is the latest news in Nigeria as of December 2025? Maybe I should change it to January 2025, January 2026. So let's see what we get from this. So using the GPT-OSS. So what I would advise, like I've been saying, is try this with different configuration, different models. Try to use the same model for both the critic and writer nodes, and try different combinations of different models for either of the nodes where you use different models for each one. Try different queries, and I mean that gives you a feel of how this runs, because that will become useful when we do more chewy tasks. Does anyone have any question? Does anyone have any comment? Yeah, Kenneth, please go ahead.
Okay, so I have a so when we are building a real world project, so it will be advisable to use a paid service such as maybe as what like you just like used, or maybe Anthropic, or because seems it provides us with detailed and much more like comprehensive my returns as much more than what like Grok also like give us.
Grok still has a paid service. Grok still has a paid service. With the free tier in Grok, you get essentially the same models that you will get when you're using a paid tier, right? The only thing is that the user limits, you have more generous user limits when you're on the paid tier, and the higher the tier, the more generous the limits are. That's all. So with the free tier, you can, if your query is complex, or you have maybe the results, the report is verbose, and maybe you go through multiple cycles of revision, you can easily hit token limits, or any of the usage limits. So Grok still has paid tiers. Now, about using a paid service, I would rather say use a model that is powerful enough for the task you're doing. It must not be paid. For example, you can still run the model I used here was GPT-OSS 20B. You can still run that model on Olama. Olama provides that same model. The thing is that in Olama, you're typically just limited by your hardware. So if you have the machine to run more powerful models, why would you go using a paid service? Somebody else paid service, that when you can run it free, in the sense that you're not paying exclusively, even though nothing is really free. right? But if what you're doing can be a smaller model like the Llama 3.2 that I have here can serve, why would you, and can serve and serve beautifully well, why do you need to go for a huge model that becomes an overkill? So essentially, just use what is what delivers the based on you. It depends on your use case, right? Which model is suitable for your use case? Can you run it locally? If not, what provider can you use? The provider that gives you what matches whatever architecture you have for your application. Does that answer your question
No,
adequately,
okay.
Kenneth? Okay. Does anyone
Yes,
else?
but like I have
Okay.
like one like thing also to say.
Go ahead, please.
Okay, so I think like there's also like one like limitation. Maybe if you are building an application and you want let's say a client to see what you are doing, Olama on your local machine like wouldn't help unless maybe like you rely on Grok, maybe like the free tier. So yeah, like I just like wanted to chip that in.
That if you want a client to see what you're doing, in what
Yeah.
way, please? You want the client to see the results
Okay.
of your execution,
Yes,
or
maybe the end results of the application that you've created, and you just send them a URL for they to explore or just go through what you've done.
okay, if you are sending, if you want them to run the scripts themselves, and if they are savvy enough to run the script, then they should also be savvy enough to have to run a local instance of Olama. But if they are not savvy enough that you just want them to click maybe a link and view that, then you probably would have packaged your app such that you're running it and they are just consuming. So in that case, it doesn't matter whether they have Olama or not. I mean, if you visit a web app, do you get to interact with the complexities in their backend, for example? So it really depends. I mean, if your clients, I mean, there's no one size fits all, right? Some clients would actually even specify that they don't want you to push their data to some other um, enterprise system. They don't want their data to pass through some other system, and they prefer locally hosted um, models. But if your client happens to be a given provider, they typically also want it to run on their own infrastructure. So they might specify, hey, don't use this other person's models. So you just do what works best in the context that you're working in.
Well noted. Well noted, sir. Thank you.
Does anyone else have a question or comment? Okay, no one else. Task stage 4 task. The stage 4 task has been uploaded. I think it has been uploaded since Tuesday, and the deadline is either Tuesday or next Tuesday or so. So please try to complete the task. I've noted that in almost all the tasks we've done, most persons do not meet the specifications of the task. Some people meet some specifications and ignore others. Some people, maybe because a particular specification is not so simple, they just ignore it like it doesn't exist. It's important that you try to meet all the specifications, because if you're working for a client and you just ignore a specification, that could be essentially lead to a project failure. So please try. If you encounter any challenges, or if you need some clarity in any of the task specifications, just DM me, or you could even ask the question in the channel so that everybody can benefit. If it is an answer that I think would not be helpful to others, in that it would deny them of the opportunity of trying to figure out things themselves, then I could give you an answer by DM. Well, please don't ask me to solve tasks for you. The essence of the task is for you to exercise your own muscles, which helps you to become better and better in building agents. Okay, ladies and gentlemen, if there is no other question or comment, I think we'll just call it a night and we'll meet next Tuesday. Hopefully by then, more of us will have been promoted to some of us. Okay, probably not, because I think deadline not have expired by then. Okay. Okay then. Good night, everyone.
Right. Good night,
See you
sir.
on Tuesday.